people who are new to this, you can log on to Slido.com. You can do it on your desktop, or you can download the app. Once you open the browser, you go to Slido.com. This is the event code, which is 36424. This will bring you to this event. And in that event space, you'll see the question and answers as the screen shows you. There's the question and answers and the polls. If everybody can just go on to Slido.com and enter the code 36424, just to make sure that you have access to it. This is what you should be. This is what the interface would look like for you guys: the question and answer and the polls. Deepika is going to enter a question for us over there. It's going to be a poll. Have you attended the Data for Good event before? This is what you should be seeing. Okay. I will give you guys some time to get onto Slido and make sure that you guys see this out there.
The code is 36424, by the way.
Yeah.
I'm going to put it in the chat.
Yeah. 36424.
And just a reminder for all the people who are coming in to put yourselves on mute. Thank you.
Okay, I'll give a minute to everybody who's just joined in to make sure that they have access to Slido, because this is where most of the conversation, if you have any questions for the guest, this is where they will be answered. I mean, this is where we'll choose the questions. Okay, I will move on. I'll start introducing our host for tonight, Eunice, who's our community lead for Data for Good. Hi, Eunice.
Hey.
And we have Asha, who's our data cleansing co-lead. Hi, Asha.
Hey, hello, everyone.
Okay. And this is our guest for tonight, Josh Starmer. He is a teacher who actually started on genetics researcher, but today he's on YouTube. He loves music, he loves teaching machine learning and statistics, and somehow combines them with music, which is amazing. He has a channel, StatQuest, that basically focuses on breaking down complex topics such as artificial intelligence and all these for bite-sized pieces so people like us to understand better. And fun fact, he has 7 musical albums. Hello, Josh.
Hello.
Okay, 1 second. And from here, I will hand it over to Eunice and Asha to start.
Cool. Did you intro Josh yet in depth?
Yes, you gave me a nice introductory.
Sorry.
Josh, do you want to talk a little bit more about yourself and just talk about how you do YouTube on StatQuest and also your background?
Yeah, so my background, I'm a computer scientist and a bioinformatician by training, and I've been doing that for a while. But I used to work in a lab, and in that lab there were all kinds of people doing research, and they were doing really cool stuff. And I did all the statistics for them, and I didn't want what I was doing to seem like magic to them. A lot of people go into biology because they don't like statistics. And so I didn't want them to think what I was doing was magic. So I used to make these little presentations so that to try to explain things. And I eventually started putting them on YouTube. That was probably about 6 years ago. And nobody watched them for a long time. But after a while, they kind of caught on. And now I've got now this is what I do. I work on a YouTube channel full time, which is a strange life to be living. It's not what I was expecting when I was getting my PhD. But I'm really happy to be doing it. I'm going to give me a second. I got to get a little bit of water.
Yeah, for sure. In the interim, I guess we'll also talk about Data for Good too then. So I feel like I see a couple of familiar faces, but for the rest of you, Data for Good, what we do typically when we are able to go out and about is to help nonprofits with kind of data science questions. So we kind of do our versions of hackathons using data in a kind of 1 or 2 day period. But typically we do it in a location, and because we can't right now, so that's why we're doing these kind of webinars where we can kind of still discuss about data questions in the nonprofit sector. So that's why we have these fireside chats. And I think Deepika, who is the lead for Toronto, was just really interested in Josh's YouTube channel. So that's why she started bringing this topic to light.
Yeah.
Cool. So would you like to expand more on like what your day-to-day kind of looks like at StatQuest, and like it's quite different than like what your PhD was? So like give us the inside scoop of like how the going full-time with content looks like.
It's funny. So I just started going full-time doing YouTube in February. So just a few months ago is when I started. And I had a full-time job and I had a pretty good salary and everything. And I kind of felt like I was jumping off a cliff when I went full-time with YouTube. And it's kind of, the first month was just like a crazy frenzy of like, oh my gosh, am I going to make enough money that I'm to pay the rent, to buy food? Is this actually going to work? It kind of felt like I was just jumping off a cliff, and so it was very busy and very stressful for the first couple of weeks. But I'm now getting into kind of a routine where it's very pleasant. I get to spend all my time doing something I really love, which is fantastic. I don't know why, but I've always been really passionate about statistics, and for some reason, and related subjects like data science and machine learning. I've always found them fascinating, and but my favorite part is just sort of like understanding why it works. And so it's just a real treat that I can do it. So my day is because I run a YouTube channel, I get a lot of comments. And so I try to respond to everybody if they have a good question or something. Like sometimes people ask, reasonable questions. They'll be confused about something. So I like to answer all those things. So that's kind of the first thing I do in the morning. And then I like to research. I'm always trying to research my next topic because it takes a while for me to come up with a way to present it. But in the afternoon, I usually have like a couple of Zoom meetings where there's a lot of networking going on, where I'm trying to figure out if I can get StatQuest more places and see if I can't find more revenue streams. Because right now with YouTube, a lot of people have got a lot worse than me. They've lost their jobs, and that's terrible. And I feel for them. And I haven't lost my job, which is great. But because the economy is kind of tanked right now, a lot of advertising revenue is down, and so YouTube really isn't paying what I was expecting it would when I left my job. So I'm trying to like work some wheel and deal to get YouTube more places, and I'm working on diversifying sort of what I do. Like I'm trying to create a bunch of study guides that people can download, and I'm trying to make more hands-on tutorials. I do a lot of YouTube videos, but YouTube isn't really like a hands-on sort of thing. You can watch it. It's more passive. And I'm trying to come up with ways where I can do kind of programming exercises with people hands-on in a live situation. So that's been kind of fun little challenges I've been thinking about when I'm not working on my videos.
Mm-hmm. Was there, like you said, you just did it in February. So like, was there a point where you're like, okay, this is when I'm going to go full time, I'm comfortable?
You know, this is kind of interesting. I was having a meeting with my boss, and my boss is was, you know, he's not my boss anymore, but my boss, I worked for him for 13 years. He was the best boss I could have ever had. And I was just in a meeting with him, and I was just kind of doing like an status update, like, what are you working on? What are your next projects? Blah, blah, blah. And we went through all that. We talked about what I've been doing, where I was going to be in 6 months or whatever. And then I go, you know what? I'm going to be honest though. I really just want to make my videos. And my boss said, is that really what you want to do? Is that where your heart is? And I said, yeah, my heart really is in my YouTube channel. And he goes, well, that's what you need to do. And that was it. That's how the decision was made. It was just kind of very sudden and actually relatively unexpected, because the meeting was only supposed to be a few minutes. It ended up being a little bit longer, and I kind of was like, oh my gosh, what just happened? You know, I just left my job, and I ended up leaving my work 2 weeks later. My boss is such a good boss, and I feel like what he was doing is he was kind of like a parent to me in that situation, where he knew this is something I needed to do, and he knew this is what I needed to spend my time on, and he was just kind of like pushing me out the door and saying, you need to do it. You need to really do it, and don't just be kind of safe at this job. I mean, he did say if I needed to come back, I could come back. He'd always have me back. But he was really just doing the right thing, which was kind of pushing me out and saying, no, if that's what you love and what you want to spend all your time with, that's what you need to be doing. And it was really, it was a hard moment at the time, but I'm obviously it's been great ever since.
Yeah, definitely sounds like an awesome boss to have, and
Yeah.
having that like assurance. It's like, oh, if anything happens, you can come back.
Yeah, he's such a great guy. I can't. I mean, if there's the most fortunate thing in my whole life is that I got to work for him. So
That's awesome. I'm sure tons of other people have related questions with probably your YouTube career after, but we'll just jump to the next more main topic for today, which is if I were, say, 10 years old, or say your grandmother, how would you explain unsupervised learning to me?
Funny you should ask. I just happen to have a presentation. And I'm going to present my entire screen. Let me do this. Bam. Can you guys see that?
Yeah.
Hooray. So this was, the question was, how would I explain unsupervised learning to a 10-year-old? So this is my young person's introduction to unsupervised learning. So imagine we had 3 types of apples: red, green, and pink. I've labeled everything, by the way, because some people are red-green colorblind, and so I don't want to refer to something being red or green and have them not know what I'm talking about. So everything's labeled. Anyways, we were told we needed to organize the apples by color. So we put the red apples to the left side, we put the green apples in the middle, and we put the pink apples on the right side. And when we know what color each apple is, sorting them by color is no big deal. I mean, you just see a red apple, put it on the left side. See a pink apple, put it on the right side. No big deal. So bam. So now let's go back to our unsorted apples and try to imagine sorting them by color. But this time we're going to do it without being able to see the colors. So this might be because we're colorblind, or maybe we're looking at a black and white picture of apples. For some reason, we don't have colors. We don't have, in machine learning lingo, we'd say we don't have labels for the apples. So regardless of why we can't see the colors, we still have to sort them, and we still want to see if there's some relationship between them. So since we can't see color, maybe we can sort by size. For example, these two apples are the smallest. So let's put them on the left side. These three apples are pretty much the same size. So we're going to put them in the middle. Lastly, these two apples are larger than the rest. So we're going to put them on the right side. So now we have three groups of apples. We got small apples on the left, medium-sized apples in the middle, and large apples on the right. Since we can't see the three colors, we did the best we could with what we had, which were the three different sizes. Now remember, the goal was to separate the red, green, and pink apples, even though we could not see the colors. There's a little typo there. So let's see how well we did. The smallest apples are both red, so hooray, we did that well. The medium-sized apples are mostly pink, but there's also a green apple. Lastly, both of the large apples are green. Grouping apples by size resulted in this one mistake, but since we only made one mistake, the groups are pretty good. So bam! When you try to cluster apples by color without knowing their colors, we're doing a type of unsupervised learning. And in machine learning lingo, we'd say we're trying to cluster or process this data without having any labels as to what the data are. Rather than using labels like color to form groups, unsupervised learning looks at the data we have at hand, like size, and it uses that data to form clusters. Double bam. So that is my little presentation to introduce unsupervised learning to a 10-year-old.
Yay! I think it's awesome because like the colors and all the pictures are definitely perfect for a 10-year-old.
Thanks.
I think probably your videos have more depth and complexity than just to a 10-year-old though, right?
Yeah, I mean, we go through. I mean, we do some pretty complicated stuff, and I don't know. I don't know if I have any 10-year-old viewers, but I think I actually have a bunch of high school students and a bunch of. Every now and then, you get a really young person who you can tell they're young because they don't know basic statistics terminology like mean or variance and things like that, and I'll get those in the questions. But to be honest, it's still kind of cool that someone at that age is interested.
Mm-hmm.
You know, so it's pretty exciting that all kinds of people are watching these things.
Yeah. So would you say like in terms of unsupervised learning techniques on census data to identify like natural clusters, would that be like a good idea in terms of an algorithm to use, or like what would be like some other algorithms that would be best for, say, turning census data into identifiable natural clusters?
I mean, I think unsupervised learning, one thing that's cool is because it's unsupervised, it can kind of reveal things that you hadn't thought of before. Groups, it can cluster things in ways that you'd never expected. And you can kind of see new patterns, which I think is a fantastic approach. You know, some of the most common unsupervised learning methods are sort of clustering methods, which I was just sort of vaguely talking about. But there's also more sophisticated methods like principal component analysis. This is one of my all-time favorites. And what's cool about that method is it does this clustering, or not, you know, it sort of like shows you, you know, with census data, you're going to have a lot of things. I just filled out my census form, and I filled out, I don't know how many questions, a bunch. And so you got a lot of things, and what that results in is, you know, a high dimensional data set. It's actually very hard to visualize or view. And so PCA, principal component analysis, is a nice way of like taking something that's like way too high dimensional to view and like then flattens it into a nice 2-dimensional graph that you can look at And it's cool because you can kind of look under the hood of what it does, and it'll tell you why, what was important in flattening all those dimensions, what was not important, what kind of features you should focus on, and what kind of features you might not need to focus on. And so it's a pretty cool process. But yeah, there's lots of methods, and I mean, I think it's a great way to explore a data set where you don't already have a lot of knowledge of going into. And I'm not I don't work for the Census Bureau, so I wouldn't know. So it'd be kind of fun to just kind of like see what happens. And I think unsupervised learning is a great place to start for that.
Mm-hmm. Yeah, you mentioned PCA, and I think it's like really great just to show visually, because then you can show other people who are not, say, like stats heavy or like more just like business people, and just like in a visual kind of show them what the biggest dimensions are or factors. But in terms of like, I guess, other unsupervised learning algorithms, what are like some of the biggest, most common ones used, and like why are they most commonly used?
I mean, there's three really, there's a bunch. PCA is probably the all-time most popular. It's probably dependent on what field you're in, but the field I'm in uses a lot of PCA. I used to do help out with people that were sequencing cells and figuring out which genes are active in the cells, and they would measure transcripts from 20,000 different genes, and they would do that in 1,000 different cells. And PCA is a really good way to kind of like deal with that much kind of high dimensional data. But also k-means clustering is super popular. It's really awesome. Hierarchical clustering is very common and popular. There's some other sort of visualization heavy unsupervised methods like tsne and UMAP. Those are great for generating plots that are easy on the eye. They generate graphs that are pretty easy to look at. Oftentimes the graphs look better or easier to interpret than a PCA plot. But the downside for methods like that for tsne and UMAP is you can't really look under the hood and see which variables or which features were most useful, and they're mostly just for visualization.
Mm-hmm. So I guess like if you got like a random data set and then you were like, okay, I had to apply unsupervised learning on it, what kind of are like the like thoughts that like of steps, I guess, that you would do to kind of like look at that data and start like doing something with it?
I mean, it's a good question. I mean, and in my field, every time someone gives you data, there's something wrong with it. So you probably all know that routine. The very first thing you do is try to fix the data. But I do a lot of visualization in R, so I'd import it into R, and I would what would I do in R? I don't know. I would try PCA. That's sort of the first thing I'd do. But there's a bunch of different ways to visualize data. PCA is one. Heat maps. If your data is suitable for heat map, that's a great way to apply k-means clustering or hierarchical clustering to those. So I would, and I would try tsne and UMAP. I just kind of throw all those things. They're all pretty easy and straightforward to do in R. You don't have to, like one or two lines of code. It's not a big deal to get them running. So that's probably what my process is, and I just do them all and see what I get. And if anything looks interesting, take it from there.
Awesome. I think we're gonna check in with Slido just to see if there's any quick questions that people might be having. Oh, okay, this one's really good. Do you have any success stories that you might have with using unsupervised learning in the industry?
Any success stories? I mean, so I work in an academic lab for 13 years, and I mean, yeah, I mean, yeah. So there's an interesting story. So I started working with this guy, a coworker of mine, and he had one of these really large, complicated data sets, and he was interested in studying how your gut, this is academic research. So basically, he was interested in so your intestines, they kind of, it's I'm talking about his research, so it's kind of hard for me to find the words for it. But basically, your intestines, every like 10 days, all of the cells are renewed. Your intestines are constant. It's sort of like your skin, right? Your skin doesn't just peel off and you die. Your skin is constantly being rebuilt. As skin cells fall off when you brush your skin, there's new skin underneath there. And the same thing happens with your intestine. It's rebuilding the lining all the time. And he was interested, and so there's all in the intestine, there are these stem cells that allow for this constant renewal. And he had this really large, complicated data set for the intestine. And I did exactly what I was just talking about. I did a PCA, I did a T-SNE graph, I did heat maps, and we were able to find some interesting genes that were related to that process by looking at all that data. And actually, we were so successful, we spun this off as a company, as a standalone company for analyzing this particular type of data. And so that was a big kind of pleasant surprise when he gave me his data. I didn't realize that like 6 months later we'd be filing for an LLC and applying for startup funding. So that was kind of an unexpected surprise and a success with unsupervised learning. Yeah.
Awesome. Somebody also asked, what's the worst possible scenario to use unsupervised learning methods?
I'll tell you the worst possible scenario is this. So unsupervised learning will find pattern and it will cluster things, regardless of whether there is meaning behind that. And so one thing you have to do when you do unsupervised clustering is you have to come up with some way to validate that, whether it has meaning or not. And one way you can do that is say, look, you've got census data, and which is a huge, huge pile of data. You could start with a small subset of that data and do some clustering and do some hierarchical clustering. And you could then look at it and go, oh, this is kind of interesting. These clusters are interesting. Well, now, once I've just identified some interesting things, what I need to do is validate those things. And my hypothesis is if I use another chunk of that census data, I should find the same clustering. That should carry over to a bigger picture. So you can use hierarchical clustering to develop hypotheses, but they're not your conclusion. You've got to validate what you find because it will find something. Whether or not that's useful is dependent entirely based on validation. And so if you're not planning on validating what you see, the clusters that are found, you're just going to report the clusters, say, hey, these are an interesting cluster, then that is a terrible time to use unsupervised learning. That is a disaster waiting to happen. So that's probably the absolute worst case scenario.
Yeah, sometimes you always have to look at the results and go like, does this make sense? Like using your common sense.
Yeah. But even when it makes sense, you can be fooled by a false positive and sort of spurious associations. Where people are really good at talking themselves into thinking they understand what they see. That's like a human instinct. Is when I see something that looks like a pattern, I'm going to go, oh yeah, of course that makes sense, and I will rationalize and I'll come up with a reason to justify why that exists. But unless I back it up with hard statistics and validation in other situations, there's a good chance that what I'm seeing is just a figment of my own creative imagination.
Mm-hmm. And also earlier when we were talking about like you just apply a couple different algorithms on the data set and see what comes out, some other people were wondering like how do you evaluate between choosing like which one's the best algorithm and then knowing like what to do with it?
Yeah, so those are all great questions. the sad thing is that it really is, with unsupervised learning, it really is subjective. It's not like a supervised method. You can create a confusion matrix, and you've got all kinds of metrics that you can use to evaluate how well that thing does. So my way of dealing with it with unsupervised thing is like, I'm very pragmatic, and I go, did this give me a useful hypothesis to test? And if so, then yes, this is useful. If it doesn't, then it's not useful. It's a real simple, how useful are the results. And if the results are useful, great. And if they're not, no hard feelings. I'll just try another method. So.
Mm-hmm. So is there like a limit of like how many different things that you try until you're like, okay, I've tried enough?
I just try for unsupervised learning, I try what the methods I've been talking about. I'll do PCA, I'll do t-SNE, I'll do heat maps with k-means clustering and things like that. And I'll just do a handful. I don't even know how many more. I'm sure there's tons more, but those are the main ones that I use. And if none of those give me great ideas, I just scratch my head and go, well, maybe next time.
Or look onto Google and
see exactly. Look on Google.
Someone also wondered, how big should your data set be for it to be successful?
That's a subjective question. It sort of depends on what you're trying to say. I'll be honest, I really don't know. It sort of depends on what the data is and what you're hoping to get out of that. As always, in anything that's sort of data driven, more is better. But sometimes you can actually prove a hypothesis with just 3 observations or 6 observations. And so I'm not going to say a small data set is a waste of time either. Sometimes that's a small data set is all that you really need. So always better.
For sure, always.
Always.
Yeah, and then having too many clusters is also like really difficult to like interpret as well. So there's an interpretability aspect of it as well.
That's exactly right. Yeah.
Someone also asked, is Python or R the best tool for this? And why do you like using R?
That's like the eternal question in data science: Python versus R. They're different. There's certain things I like about R that I really like about R. R has built-in handling for missing data. It has a data type specifically for missing data, whereas in Python, it's sort of very ad hoc how to deal with missing data. It's not nearly as easy. And so from a data scientist perspective, R is, because there's always missing data, and that's always a problem you have to deal with. R from the get-go has a nice way of dealing with it. And a lot of the functions that you use in R, you can just automatically say, ignore the missing data or deal with the missing. Most of the functions have ways of treating with it automatically. So that's very useful. Python, on the other hand, is great for sort of developing sort of production environments. So a lot of people who are in machine learning and they want to develop sort of an industrial strength pipeline for doing machine learning. Well, Python's a great place to be doing something like that. So I feel like they both have strengths and weaknesses, but for just sort of like raw, sort of like just looking at the data and exploring the data, I like doing that in R because there's a little bit less overhead in terms of dealing with how to clean your data up and fix your data. And that's, for me, the most annoying part. I'd rather be drawing graphs than worrying about how to deal with missing data. But I do a lot of stuff in Python as well, so I'm not going to say one is better than the other.
But someone also asked, for unsupervised learning, can it be kind of used together with any other like deep learning or reinforcement learning techniques? And if so, like, can you share an example?
You can definitely combine the methods, and I think often unsupervised learning is sort of like first step to doing supervised learning. Like like we were saying, like unsupervised learning can identify ways to cluster the data and identify ways that you may then go, well, let's label this cluster, even though we didn't have a label for these people beforehand. Now that they're clustering, let's give them a label. And that's what we've done in the laboratory. When we were looking at these intestinal cells, we noticed that some of the cells were doing one thing and other cells were doing another thing. And so we were able to label this group as, you know, I don't want to get too technical, but, you know, imagine these cells generate more intestinal lining, and these cells over here, they are more stem cell like, so they're making more stem cells, or they're helping protect or feed the stem cells. And so then, you know, once we've labeled the cells, well, then that's a great place to then bring supervised learning into, because supervised learning has a nice way of like I said, it's a way it's got ways of quantifying how well it's performing. You know, the purpose of supervised learning is to be as accurate as possible at classifying things into these known groups. And once we know what the groups are, that's what we want to do, is we want to be able to take new data and accurately put it into one of these known groups. So,
there was one question that was really great here. Is there a potential to model stocks with unsupervised learning given our current situation? I guess somebody's really interested in that oil stock going on.
Oh, I know. I mean, it's probably a good time to buy, to be honest, because it will go up. You know, it has to, right? Once the virus goes away, we'll start burning oil just like we used to. I mean, don't take that as investment advice, and don't sue me if you lose money. But I'm not a licensed broker or anything like that. You know, I don't know. I've got a good friend who he's always trying to model the stock market. He's always got these algorithms, these genetic algorithms or whatever. He's always trying to model the stock market, and he's been doing it for years, and I don't really know if he's had much success. You know, if that's your thing, go for it. There's a lot of great data sources. I was just playing around with Yahoo Finance, which is maybe one of the. It's a pretty cool site. It's super easy to interface and download stock market data, and it's fun to play with. So go right ahead. I mean, maybe you'll make lots of money, and then you can support me.
I think for that one, you definitely need a lot of domain knowledge.
Yeah.
He probably needs a lot of like finance knowledge to know what to do. But that leads me to some other question that somebody asked, which is how important is domain knowledge versus statistical knowledge when doing this?
I mean, in general, I mean, it really depends. I think what's more important than domain knowledge is is a willing to learn. Because there's one of my favorite things with data science is collaborating with people that are domain experts. I love working with people and helping them with their problems. That's one of the driving forces in this field, because data science is really sort of nothing in a vacuum. Data science is, to me, all about collaborating with other people and helping them make good decisions or helping them make a new product or something like that. It's not sort of like an end of itself. And so rather than worry about how much domain knowledge we have, what I'd worry about is how willing I am to learn new things, because people want data science and machine learning people to help them. And so they'd probably be willing to teach you whatever it is they're doing. And that's what I found in the lab. I mean, I went in never having done an experiment before in my life, and next thing you know, they got me with gloves on and measuring out extremely small volumes of chemicals and putting them into little plastic things and swirling them. They totally wanted to teach me every little step, and it was really fun learning, because the more I learned about what they did, the more I learned about how to do what I do as a data scientist better. I learned sort of what kind of mistakes can come, what happens when you're actually doing the experiment, what kind of mistakes can occur. And that made interpreting the data a lot easier, and sort of realizing, when an experiment was a good experiment or a bad experiment. And that gave me a sense of what data sets I should spend more of my time on.
Someone was also curious about how effective is unsupervised learning to detect outliers. So I guess in terms of outlier and fraud detection, would this be like a great algorithm, or would there be other better algorithms?
I would guess there are better algorithms for fraud detection than unsupervised learning. I don't know. That's a good question. I really don't know. I'm thinking about it real hard as fast as I can in the back of my head right now. But you can imagine a little mouse just on a wheel, just going as fast as it can. But I don't know. I hadn't thought about using it for outlier detection, and it does make me wonder if there is a kind of a cool use for it in that context. Because the whole point of the outliers is you don't really know. You've never seen it before, so how can you train a model on that?
Yeah. Normally, I've seen it on supervised learning because that's easier to see it.
I've seen a lot of like there's certain kind of like support vector machines that are specialized in outlier detection. But maybe there's a cool use for it. I don't know. I don't know the answer to that question, but I am thinking about it.
Yeah. Maybe I'll put it in your future YouTube video.
Exactly. It sounds like a fun little puzzle to work on. I mean, it could be cool.
Yeah. Speaking about your future YouTube videos, there's quite a lot of questions about that. So somebody was asking, what's your process for turning a written lesson plan into a video? And I guess like some other softwares that you might recommend. I guess this person might want to be a YouTube star in the future too.
So the process, unfortunately, is very lengthy. I wasn't born understanding all these things, so I have to research all of them. And that depending on the topic, can be can take a little bit of time, or it can take a long time. Like when I made my video on PCA, I spent 2 years researching PCA to try to come up with a really simple way to talk about it that conveyed all the important ideas, but did it in a way that anyone could understand. That video, the sort of the back end of that video, took 2 years to do, but it paid off, and then it's one of my most popular videos. But yeah, I do a ton of research. And oftentimes what I do when I do the research is I see what other examples people are using, and I see how they're trying to explain the concept. And the assumption I have is the reason someone's going to come to StatQuest is maybe they saw this explanation and it didn't make sense to them. So what can I do differently? What can I use a different data set? Can I have a different approach? What are these people doing that might not be communicating the understanding as well as it could be? So I try to look at what people are doing, and I try to find what's missing. And that takes a long time too, to kind of, because oftentimes when you read, we're reading what's there, we're not thinking about what's not there. And so I have to kind of figure out what's not there, and then I focus on that aspect. That's my secret recipe right there. That's my secret sauce. Is when I look at how other people explain a subject, I figure out what they're not explaining, and then I focus on that aspect. And then I just start. The other thing is I'm very visual. I have to have pictures to understand something, and so I just start trying to draw a picture of whatever the method is. If it's support vector machines, I don't care how mathy and how much matrix algebra they have on the page. I've got to have a picture. And so I start coming up with ways to illustrate how that thing works. And so that's part of the process. Another part of the process is, and this is also iterative, is once I've developed my picture, I then start walking my picture through the algorithm. And the data in the picture, and I see what happens to it. and then I check that with running the actual data through the actual algorithm, and I see if my picture gives me the same results as the actual algorithm does. And if it does, I know I'm on the right track, and if it doesn't, it teaches me I need to learn more. And that's also part of the validation. That's one way I can be real confident that I'm doing a good job, not necessarily a good job explaining it, but I'm accurately representing what the algorithm is doing. Is if my little pictures can create the same results as the algorithm, then I'm usually thinking, yeah, well, this is good. This is validation.
Is there like a specific software or tool that you use for drawing the visualizations?
I love Keynote.
Oh, okay. I thought there was something like crazy.
Yeah, if you have a Mac, I'll show you. I'll show you my entire screen. We'll share this. I don't. Can you see this?
Yep.
So yeah, it's got nice little drawing tools, and you can draw little arcs, and you can come over here and you say, I want this to be a red arrow, and you can click on it, and I don't know. I just love Keynote. I do everything in Keynote. It's just like PowerPoint, except it just makes things look a little nicer, I think, aesthetically pleasing to the eye.
Yeah.
Yeah.
Pretty simple. Somebody is thinking of content for your YouTube channel. So do you have any plans to release content on your YouTube about analyzing open data for COVID?
Yeah, I mean, I've been thinking about that, and I think it's a great idea. So whenever I do a video, I always like to have a data set that I'm working with. And so, obviously I could use COVID data as sort of a starting point of trying to explain how an algorithm works. But what I'm trying to develop right now are, like I said, at the very beginning, I don't know if you were here for that, but at the very beginning, I said, I'm trying to develop more interactive content where we take a data set and we take it from all the warts and messiness of when you first get it, and we're going to take it through every little step, and then we're going to do support vector machines. We're going to apply that to that, and then we're going to optimize the hyperparameters, blah blah blah, and all that stuff. And the COVID data would be a fantastic source for that, just because a lot of people are interested in it, but also who knows, what we might discover something cool. So it'd be a fun data set to use.
Mm-hmm. I guess these are more skills based. Oh, somebody's a subscriber of yours on this video, but these are more skills based questions. But somebody was asking, how do we know our analytics skills are helpful to solve like social problems, and where they might not be helpful to help other people? That's kind of a vague question, pretty open-ended.
Yeah, I know. I guess I would say the most important, like I was saying earlier, I think the most important skill of a data scientist in any field, not just sort of social sides or scientific sides or artistic sides, the most important skill to have is to be a good listener, and listen to what the people need, and don't just go in and say, oh, I've got all these awesome tools, I'm going to solve your problems. It's important to listen to people and find out what their problems are before that. And that's the most important skill. And then once they start asking you, they start showing you what their data is, they may not know all the things you can do with your data. And so you bringing in a big toolkit can be helpful. And you could say, hey, I've listened to what you say about your data. You've shown me some things, and I think this is cool. But I have these cool tools which might generate these results. Would you be interested in something like that? But again, it just leads to more listening from the other people. And I think as long as we're willing to listen to what people say, we can do good. We can do good things.
Yeah, data for good.
Data for good. Yeah.
Somebody was also wondering, I guess this is more general, but do you have any recommendations for instructors who are moving online?
Oh, I mean, I don't know. I'll be honest, I don't actually watch. I have a YouTube channel. I rarely watch other people's educational things online on YouTube, partly because I'm afraid if they do a really good job, I'm just going to want to copy them. And so I actually actively avoid watching other people's presentations on YouTube. And so I'm a terrible resource for that kind of thing. I can recommend a book. That's about all I can do.
I guess that's kind of related to this question that somebody was wondering too. Like, if somebody didn't think stats is useful, what would you tell them?
I mean, I'd tell them to go to. I mean, I don't know if they don't think stats are useful, then that's a hard proposition. I mean, statistics are statistics are the foundations of making decisions, even if they're not, doing a t-test or something. When we make any decision about what time should we eat dinner tonight or something like that, that's based on a lot of experience and knowledge that, like, if I wait too long, I'm going to get hungry, and things like that. If I wait way too long, I'm going to get hangry, and I don't want to do that. And we're saying, well, what's the probability that I'll get hangry if I wait 4 hours? It's really high, so I better eat sooner than that. We're using statistics in an intuitive way all the time. However, like I was saying earlier, people are, I think we're hardwired for identifying patterns. And a lot of those times, patterns may not mean anything. And statistics is the only tool we have to separate the meaningful patterns from the random noise that's just luck and things just happened that way. Because you go out in nature and I don't know. I think I'm kind of freestyling right now, and I don't really even know where I'm leading this. But an example I often have is if I took 1,000,000 pennies and I just threw them on the floor in a completely random way, and I looked close enough, there's going to be places on that floor, patches, where every single penny is a heads, right? And I might look at that and go, these are all magical pennies because they all landed on heads close to each other. But if I throw enough pennies on the floor, patterns like that are just going to randomly occur. And our only defense against thinking that we've got a pile of magical pennies are statistics. So that's my justification.
You were talking about earlier, like, books that you would recommend. So, like, what are some top books that you would recommend for people?
My favorite book for machine learning is the Introduction to Statistical Learning. It's a free book. You can download it for free. I have a link to it on the StatQuest website, or you can just Google it, Introduction to Statistical Learning. It's a fantastic book. A lot of my videos follow that book and just illustrate it in an easier to understand way. So you could get that book and you could say, well, I'm reading this book and this thing, I mean, everything's making a lot of sense and I'm happy, but this little thing, I'm stuck on this one detail. Well, I probably have a video about that detail. So you could watch my video and you'd be like, oh, I get it. Now I'll move on to the next chapter. I really like that book. I've learned a lot from that book.
Yeah, it's the yellow one, right? The 3rd edition or something like that.
Yeah, and actually, for free, you can download the 7th edition.
Oh, okay. Upgraded.
Yeah.
I think that's most of the questions, and we're almost out of time anyway. So we have one more minute. Is there any kind of like closing remarks you would like to leave our group of people?
Closing remarks. Have fun. Data science is great. I enjoy it. And if you can, do good.
For sure. And that's why we're here. We're going to leave links to your channel for everyone. And also we're going to, Anam, do you want to do the closing remarks for us?
Yeah. Thank you, Josh. That was amazing. For everybody who tuned in, we'll share the link. Please do follow. If you want to learn more about all the fantastic things and the music that he makes, please follow YouTube channel StatQuest. We'll share that information. Just a quick announcement for next event. That's on April 30. on April 30th with Wisely. It's an AI platform for fundraisers to predict donor insights. And we will talk to you guys then.
Thank you. Thanks,
Thanks,
Josh.
everyone.